Hey guys, Mike here. So this video is going to be a video on the district steam heating system in New York City, or as I call it, City Steam. Now, Con Edison back in the late 1880s built the first steam plant downtown on 14th Street, East 14th Street, right off the East River, and that supplied steam to the buildings in the surrounding area, and I think there was one down even further that supplied steam to the Wall Street area. You can look up the history on Wikipedia and online, but there is like 50% of buildings in New York have city steam, and the other 50% all have boilers. I mean, the buildings in New York that have boilers still outnumber buildings with city steam, but I think, yeah, they do actually. City steam is more in commercial buildings and in certain areas of New York. Upper West Side, Upper East Side, Midtown, Midtown East, Midtown West, Lower Manhattan, around there. A lot of, more commercial buildings have city steam. And city steam is a very simple system. This building has city steam, and I'm going to go over the system and the components. So this right here is the main steam shutoff valve right here. This is where the steam comes in from the street. These are metering devices. They meter the steam in CFMs like they would for natural gas. So it's metered the same way as natural gas, and every week someone from Con Edison comes in here and reads the meters like they would an electric meter or a gas meter. It's just the same thing, only it's a steam meter. And there's one back here too. Now the steam, when it comes in, it splits off in two different directions. This side goes up and over to a heat exchanger to heat the hot water for the building. This side comes up and over here to heat, for heating for all the radiators in the building. These are called Spence valves. They're pressure reducing valves. I did a video on the Spence valve and how they work. This building has two wings, therefore there's two Spence valves for the front wing and the back wing. The steam comes in the street here, usually about 180 pounds of pressure. You can see right there, that's about 100 and maybe 190 actually, because 200. So it's really high pressure coming in. These are the first Spence valves that reduce the pressure down to 50 pounds. As you saw in the last video, 50 pounds of pressure coming here. These are the secondary Spence valves. These Spence valves bring the steam pressure down to 3 pounds of pressure, which is the normal steam pressure you want to have in the building, depending on your building, between 3 and 5. Now these do roughly 3 pounds. Sometimes the steam comes back at 5 pounds. These are the other Spence valves. And then these lines go out into the basement and up to the building into the steam risers. Now I'm not going to go over how the Spence valves work because that's covered in another video, and I'm running short on time, so I don't have time to do that. So this line here goes up, and there's a little pressure reducing valve here that brings this steam pressure down about 30 pounds, and that goes over to the heat exchanger. This is like a little bleeder line here. That line comes over here, and that goes down to another Spence valve that brings it down to about 2.93 pounds of steam pressure. And that steam, put the light on here. That steam, yeah, I put this new LED light up here a while ago. That steam comes here, you can see it's right below 3 pounds of pressure. And there's the other Spence valve back there. That steam comes in here, in coils, okay, heats the hot water up to about, right now it's about 175, it's usually around 180, 175, around there. That hot water gets heated up, comes out into a Hobie valve, which is a mixing valve, a fixed mixing valve, but you can change it by here. Goes up here with cold water, main hot water valve, original hot water valve. This building was built in 1929. Then usually we come down to about, we got 125 Fahrenheit. So 125 degrees coming out. This is the return with the circulator. And then it goes up to the building. Now, before the cold water enters that heat exchanger, and to prevent from temperature shock, this is a preheater that uses the condensate that comes down from the steam. So before the steam is dumped, before the condensate is dumped into the sewer, it goes through this preheater. Now that comes off these drip lines from these Spence valves, which are always feeding it in here. So your cold water, lukewarm water goes into there first, and then it gets and then the condensate runs in here, preheats the cold water, which feeds into there, which then gets heated up and then goes to the Hobie valve. So there's no temperature shock to crack that heat exchange or anything. Now another place that condensate comes from is our vacuum tank. This is the vacuum tank. On this side, these are two 5-horsepower motors driving 2 vacuum centrifugal pumps. These are the vacuums. Okay? These help to pull the condensate down through the steam system. Now, one thing about a vacuum tank is you are not to use this to help heat the building. You still need to send up steam. You need to send up steam pressure. The only thing this does is it sucks the condensate back down. But in ways, it does help to draw the steam up to the higher floors quicker. But pulling a really strong vacuum isn't going to help you heat the building quicker. You need to back it up with enough steam pressure. If you have 3 pounds going up, and this thing is pulling it like 7 pounds, minus 7 pounds in the mercury, that's where that line is. The highest ever got it was like 20. You're doing good. It'll help it. It will help it to a point, but it's not like you can run 1 pound of steam pressure and 20 in mercury of vacuum. You can't do that. It's not going to help the steam go up any quicker. It's not going to just pull it through. So you need to have enough steam pressure back in that vacuum. But once those two are equalized and they're perfect, you have no problems. This also helps with banging in pipes because the condensate's constantly getting sucked down. Once the condensate fills up in this tank to a certain level, there's 2 pumps here. These condensate pumps pump it up over through that pipe, comes down here right into the preheater. The hot condensate goes through the preheater, preheats that cold water before it goes into the main heat exchanger, and once that water is done, comes here, and this pipe here runs under the floor and into the sewer. And that's the condensate line. So that's how that works. And that's the preheater, that's the main heat exchanger, and that's our steam, that's the vacuum tank. A problem with these vacuum tanks, when you get a lot of steam, if this gets to this line here, this gets really hot. These pumps can burn out because it's basically drawing air, and the air is so hot that these motors actually sound like coffee grinders. And they replaced the seal earlier this year. You can see this one had a new seal because it was leaking. Now, to prevent that from happening, last year I ran this pipe, and I did this myself. And this goes in here, and what that does is introduces fresh cold water, and we use that to cool the tank down. Sometimes we'll have it cracked, or if it's real bad, sometimes you can open it all the way. Little water hammer there. That's like 160 pounds of water pressure because that's coming right off the main feed from the water tank, so it's high pressure in there. But that goes into here, and we use it to cool the tank down so the pumps can keep running. Because if you have this high volumes of steam in the really cold months, and I'm talking like it gets like 20 degrees out, 15 degrees out, 3 degrees out, you're going to have so much steam. This tank is going to get so hot, these pumps are going to have a really hard time working. So that's where the cold water comes in. And when these pumps can't work efficiently, they can't pull a vacuum. And that's really bad because you'll have this tank at 180 degrees and your vacuum will be at 0. And these pumps will be constantly running. So that's why we add the cold water, help cool the tank down, it helps to draw a better vacuum, and these pumps don't burn out. I hear, before I started here as a handyman, these pumps have burnt out in the past before. But last year we introduced this line. Over here, these 2 pumps are the water pumps for the tank on the roof. They suck the water from the main coming in the street, pump it up to the roof tank, and then from there it's gravity fed through the building. Back there you have your steam traps. That's one steam trap, and then we have another steam trap over here. Now all that condensate comes down here through this valve and right into the bottom of that tank. That's where all that condensate's coming down from the steam system. This is an exhaust here from the steam room. These are some old switchboards. I can still manually do that if I want, still live. These are the old steam pressure gauges, which are pretty cool. They're no longer in use, even though that little line goes up there, so I'm not sure if that still has steam going through it or not, but it might, but they're not working. And yeah, that's pretty much the steam room. So you can see it's a lot smaller than any boiler room. It's a lot more simplified and such. The only problem with these Spence valves, like I said, is when these diaphragms go, you can have high pressure steam going through here, which is very bad. And you could say it's like a runaway Spence, and you need to get the plumber in immediately. And to do that, there is a plumbing company in New York City that deals exclusively with high pressure steam, and they're the ones who service these Spence valves. Most of the time, they'll just change out the Spence valve, because those bolts you have to heat up with a torch just to get those bolts undone. They're so torqued down. So that's usually how it's done, and that is the district steam heating system for this building. This video goes out to Gordon and Stray Current. I promised you guys I would have a video on the weekend of the system. So, there you have it. Thank you for watching, and Mike out.